In this example, we show you how to create a simple Einstein project from scratch. The example is based on the Einstein Thermal Energy Audit Guide, chapter 4.1, described in steps 2 of this example. Steps 2 and steps 3. We open Einstein, and first of all you have to create a new project. So you go to the main menu, project, and select a new project. Then you enter a title for your project. So for example, my first project. And you can add some description to this project. So we can add here Einstein Audit Guide, chapter 4.1, step 2 and 3. In this general information for the industry, we also can define the operation schedule of the industry. So you can enter here the information you have. It's a working day of 10 hours in 2 shifts and 260 production days a year. So far the general setup of the industry. Now we enter the heat consuming process in the industry, which in our case is a process for container washing. So we go to this system scheme here. We press right mouse and then we add a process. We give a name to this process. So for example here, container washing, and specify that it's a heating process. The energy demand of this process is defined by an incoming stream of water which has to be heated up. So we can name it fresh water. We select as a medium water, and we estimate an initial temperature of 10 degrees, and we know that we have to heat up until 80 degrees. The additional information we have on this process is that in each cycle of the process operation, a quantity of 100 cubic meters of water is consumed. Okay. So far to the heat demand. In our example, this process also is supposed to have a waste heat stream. So we can here add a residual energy. By right mouse clicking, we can add a stream and name it wastewater. So medium also here is selected as water, and the outlet temperature is supposed to be 50 degrees. Also in this case, we suppose the quantity of the stream to be 100 cubic meters. And finally, in order to define the heat demand, we have to define an operation schedule. In our case, we suppose that this will be 10 hours per day in 1 shift and 260 days of operation per year. And finally, we press OK in order to save our data. Okay, now we have the process container washing added to our system, and the next step is to define the heat supply for this process. So we suppose that this is done by a steam boiler. Again, we go to the system scheme, press the right mouse click and add an equipment. Give a name to the equipment, for example, my steam boiler, and select here, it's also already predefined, steam boiler. The only information we have available on this boiler is that it is fired by natural gas. So we can add this as a fuel to the system. We select fuel type natural gas. And connect it as an input to the steam boiler. Furthermore, we have to define a heat distribution, which in our case is supposed to be the steam piping. So the next component we add to the system, again with right click on the mouse, is a pipe or duct. We call it, for example, my steam piping. And here we have to estimate some data even if we do not have them available. So we suppose it's a closed circuit with 100% or recirculation rate of 1. And we estimate the temperature levels, for example, 125 forward and 60 degrees return temperature. And the heat and cold distribution medium is supposed to be steam at 2 bar. By this our distribution circuit is defined. And we can establish the connections with mouse clicking. So we connect the boiler to the steam piping at input, and at the output of the steam piping we connect it to our process container washing. In order to conclude our data input, we still add some economic information, which is the tariffs of the natural gas and of electricity. So we click on natural gas and can enter here a tariff of 30 euros per megawatt hour. And we select the electricity and can enter here a tariff of 85 euros per megawatt hour. This is also information we have available. Now we can let Einstein check if this information is sufficient in order to do already some processing. So we open the menu consistency check, and first of all we select the required level of accuracy. In our case this is a quick and dirty analysis, so we select quick and dirty and we press a button basic check. Then Einstein will process all the information at input and see which parameters are missing in our system. So you see that for a quick and dirty analysis, some of the parameters, for example the total own fuel consumption, are not known. They are not defined. But if we want to, we can let Einstein go a step beyond. We can let it do some estimates, some automatic estimates on the data by pressing here the next button, which is estimate data. Confirm with yes. Then Einstein calculates again, but doing some data estimation. And after doing this, we see that now our data set is sufficient in order to go ahead and do some calculations with this input. We can confirm by OK. And then in this section here, energy performance, we can see some information on the heat demand of the system in the present state. So far to this step. We will go ahead with the next example.